Hello everyone, my name is Skylar Swiderski. I am a tutor for the Cisco 1, Cisco 2, and many of the other IT related classes here at SSC. In this online lecture, I'll be going over common commands that you should be expected to know for the upcoming final skills-based exam. In the lecture, take note of what modes the commands are entered in. Generally knowing what modes the commands are supposed to be entered in will be very useful when you take the exam. Before I start the lecture, I highly recommend that you should be comfortable with subnetting, the general concepts of routers and switches, and understand the CLI, or Command Line Interface environment. If you are struggling with any of those topics, I suggest going back to the online Cisco textbook and reviewing those topics and concepts. Throughout the lecture, I'll be using a practice final exam worksheet and a packet tracer file. I recommend that you have the files open and follow along. I will be configuring the following in the lab: PC1, PC2, Switch 1, and Router 1. I will not be configuring Switch 2, though if you want to practice those commands on your own, go for it, since Switch 2's configurations are pretty close to Switch 1's configurations. Throughout the worksheet, there are questions that you'll need to answer on your own. I'll be ending the lecture after I complete Part 4, Router Configurations. Part 5 and Part 6 require Switch 2 to be configured. Cisco's final skills exam will test you on switch and router configuration and their associated commands. The skills exam will be timed and no notes are allowed to be used. So that means you can't use a command sheet. You want to make sure that these commands are getting memorized, so keep on practicing. The exam is worth between 15 to 30% of your grade depending on what class you are taking. Hopefully this lecture will get you more comfortable with the CLI of switches and routers. The lecture will also cover connecting devices via cables and configuring IP information on the PCs. Without further ado, let's begin. Part 1, IP addressing and subnetting. So have the student file open, the packet tracer file open, and a spare sheet of paper for the first part. Part 1 is dealing with subnetting. It says that you are a network administrator and designer for a small-sized graphics company. The company is needing a network to be set up. The IT manager has assigned you the task of creating the necessary network in its IP table. The IT manager got the address from the company's ISP, or Internet Service Provider. The ISP accidentally gave the IT manager the binary network address instead of the decimal network address. The IT manager said that you should be able to translate the binary address to the decimal form. The binary address is 11000010, 101010000, 110010000, and then the last octet is all zeros. Assume whatever the class the address may be, it contains the default subnet mask for that class. The company needs 2 networks. Your task is to convert the binary address to decimal, subnet the given address, and answer the following 5 questions. The IPv6 table has already been done for you. So, first thing that we need to do is convert the binary IPv4 address to decimal. So, looking at our bits here, we have the first 2 bits on, the next 4 are off, and then we have the second to last bit on, and then the next one off. So which ones are on? 128, 64, and then we have the number 2 bit turned on. And when you add those together, it equals 194. Going to the next octet, we have the first bit turned on, next bit turned off, next bit turned on, next bit turned off, next bit is on, and the next three are off. We have 128 turned on, 32, and 8. We're going to add these together, and that gives us 168. The next octet is 1, 1, 0, 0, 1, and then the next three are off, all zeros. So the first bit, 128, 64, and then the next one is 8. And that translates to, when added together, is 200. And then since the last octet is all zeros, that means the decimal equivalency is 0. So our original network decimal address is 194, 168, .200.0. To determine what the class is because of this, we have to take a look at the first octet number. So it is 194. 194 falls in the Class C range, so it is a Class C type, and since it is a Class C type, it has a default prefix notation of 24, or a subnet mask equivalency of 255.255.255.0. Now, since we know what the decimal major network address is, now we are able to subnet it. So, taking our decimal address here, it said that we needed 2 networks. So remembering how we did subnetting, it's 2 to the n. So how many bits do we need to steal to get 2 networks? There are some cases, as you know, in subnetting where you don't get the exact number that you want. For example, if you wanted 5 networks, you couldn't do 2 to the 2 because that would only give you 4 networks. So the next closest one would be 2 to the 3. And that would give you 3 extra networks because 2 to the 3 is 8. But in this case, it works out perfectly where we only need 1 bit to be taken because 2 to the 1 is 2 networks. So we're taking 1 bit, and because we're taking 1 bit and we start left to right, we're taking the 128 bit. So that would mean our subnet mask, our new subnet mask, would be 255.255.255.128. Because we add the bit numbers that we steal. In this case, we only had to steal 1, so it's just 128. And that would mean our prefix notation would now be 25, because we took 1 bit from the host section and we added it to the network section. So going into our table here, we're creating 2 networks. Our first subnetwork address would be 194.168.200.0, and the next one would be 194.168.200.128. And keep in mind, the number altogether, in this case 128, because we only took 1 bit again, the number here, 128, is always going to be your last network. So if we did 2 bits instead, number would be 192, and in that case, the last network would be 192. Just remember, whatever the number is here, that's your last network. Little small trick for you to use. All right. So now, since we know our subnetwork address, we can fill out the rest of the table here. So again, I always suggest doing the broadcast address. So for the first one, it would be 194.168.200.127, because we subtracted 1 from the subnetwork address here. Subtract 1, that will give us our broadcast, and we subtract 1 again, so we can get our last available host address. And then the first available one, we just simply add 1 from the subnetwork address. So 194.168.200.1. Next one here, 194.168.200.129. Then going back here, because this is the last network, we know that the last number, the last octet number, will be 255. And then the last available host in that subnetwork address would be 254. And if you check all these, again, because it is the 1 bit that we took, which is 128, each column here is going to increment by 128 in the 4th octet. All right. And you should be now able to answer those 5 questions. And now we're going to part 2 of part 1, IP addressing table. So now, since you now subnetted the network, it's now asking you to fill in the IP table using the information below and the subnetting table. So we're going to be referencing the above table there in just a few moments. So first one that we're doing is switch 1. It's VLAN. It says switch 1 VLAN uses the first usable host address in the first subnetwork. So we're going back here, and it says first usable host address in the first subnetwork. So first available host address in the first subnetwork is 194.168.200.1. So 194.168.200.1. And then, because all of them share the same subnet mask here, that's going to be 128. Okay, so now we're going to switch to VLAN uses the first usable host address in the second subnetwork. Well, first available host address in the second subnetwork, 194.168.200.129. And it has the same subnet mask. Alright. Then it says router 1's gigabit 00 port uses the second usable host address in the first subnetwork. So router 1, first one, second usable, dot 2. We add 1 here, second usable. And it has the same subnet mask. Okay. Router 1 gigabit 01 port uses the second usable host address in the second subnetwork. So we take this number here, we add 1 to it, so 194.168.200.130. Same subnet mask. Alright, next one, PC1, its NIC uses the third usable host address in the first subnetwork. So we just simply add 1 to this. So 194.168.200.3. Same subnet mask. And then PC2 uses the third usable host address in the second subnetwork. So we just add 1 here. .131. Same subnet mask again. Alright, so now we have to work on the default gateway column here. So looking to have a better visual, a default gateway, remember, is a way for any of the devices to be able to get to the router for information. So it needs a way out to get to the router to get outside of its network. Because in this case, this network here, as of right now, can only talk to each other. It can't be able to talk or contact the other network here. There's nowhere for it to send its data to. So default gateway would be these ports right here on the router. So in this case, switch 1 would have a default gateway of whatever the port IP address is right here. And then the second network would have a default gateway of this port's IP address. So in this case, this port right here would be gig 00, and this would be gig 01. So looking at our table here, gig 00's port is 194.168.200.2. So anything in the first network would have that IP address for the default gateway. So switch 1 would have that, and then PC1 would have also that same default gateway. And then switch 2 and PC2 would use the .130 address for its default gateway. Alright, so that is the IP addressing table. Make sure to save that so you don't lose your work. Okay, so now we're moving on to part 2, making connections and assigning PC IP addresses. So now we're actually going into Packet Tracer here and assigning those addresses. Alright, moving to part 2, making connections and assigning PC IP addresses. Alright, so the first part of part 2 here is making the connections. So we're going to pull up Packet Tracer, make sure that we have that up. We're going to have that to the side here. It'll make it a lot easier to pull up the IPA table and assign it accordingly. So first part is doing the connections here. So the first one, it says connect each PC's NIC to the appropriate switch fast Ethernet 1 port. So we're going to this Packet Tracer here. Look for the lightning bolt, represents connections. By default, the most common cable that we use in this case would be a copper straight through cable. We connect its NIC In this case, it's Fast Ethernet 0. It says we need to connect it to Fast Ethernet 1 of switch 1. And notice that we can fast forward time here. It works. Okay, and then we need to do the other one. So go into here, PC2s to Fast Ethernet 1. So we completed the first step of that. Then it says create a console connection between each of the PCs to the appropriate switch. So I'm going here. Remember, the console connection is represented by a light blue cable. It's the second option from the lightning bolt. Connect that to the RS232 port. Connect that to the switch to the console port. Same thing here from PC2. Connect that to the console port. Next step is connecting switch 1's gigabit 01 port to the router 1's gigabit 01. Connect switch 1's gig 01 port to router's gig 00 port. And we have to use a copper straight through cable because that's generally the most common cable type to use in that case. So we're connecting 01s of switch 1 to gig 00 port. Now notice that this just turned red. Remember, by default, router will have all of its port on shutdown. So keep that in mind when we go to configure the router. By default, the ports are shut down versus a switch that it has all of its ports turned on by default. So now we're going to switch 2 using that copper straight through cable, connecting gigabit 01, connect it to gig 01 port of the router 1. And the last one, we're going to have to use a copper crossover cable because we're linking two devices of the same type here. So gig 02 of switch 1 to gig 02 of switch 2. Fast forward time, it works. Now keep in mind, there are some rare occasions that you may need to use a crossover cable linking two different devices. So one such case, if it's a router and you're connecting a laptop or just a normal desktop computer or a server, you have to use a copper crossover cable because remember the pins for the connections are the same. So that's why you have to use a copper crossover cable for same devices, or in some occasions with servers and PCs, you have to use a copper crossover. Alright, so going to part 2 of part 2, we are now going to assign the IP addresses to PC1 and PC2. So we're going into the PC, click on that, go to the desktop, IP configuration, pull that over here. And now we're going to look at our table, PC1. Now we need to plug in all this information because it's saying that we need to give it the IPv4 address, the IPv4 subnet mask, the IPv4 default gateway, the IPv6 address, the IPv6 prefix notation, and the IPv6 gateway. Alright, so looking at our IP table, we're going in and let's give it the IP information here. So 194.168.200.3. Press tab. It gives us our first 3 quadrants. We just have to edit the 4th quadrant. We press tab again. Default gateway. Our default gateway was 194.168.200.2. Leave the DNS server blank. Going to the IPv6 address here, which is 0002. So to get the full address, we have to go here, 2001 DCB8 ACAD FFFF BADE 9AA9, CAD0, and then it was 0002. So 3 zeros followed by 2, prefix notation of 1, 2, 3, and then we're going to then assign it the IPv6 default gateway. So in this case, it would be FE80::1, and that is the IP information for PC1. So again, 194.168.200.3 for the IPv4 address, subnet mask of 255.255.255.128, default gateway 194.168.200.2, IPv6 address. Again, we used the second table there to get most of the address, and we just filled in the host portion, gave it the prefix notation as said in the table, used the IPv6 default gateway, and that should be it for PC1. All right, go to PC2. Same thing, go to desktop, ipconfig, and then plug in the information to PC2. So PC2, 194.168.200.131. Change the subnet mask, fourth quadrant, 128. Default gateway of 194.168.200.130. Skip the DNS server. Going back here, the IPv6 address, in this case, is almost identical, except 2001, it will be 2002. Fill out the rest of the IPv6 address here. And remember, PC2 use 0002. We have the same prefix notation. Skip the link local. Go to the IPv6 default gateway. Plug in FE80::2. Leave the DNS server alone. And that should be it for PC2. All right. So now we're going to part 3, switch configurations. All right, so remember in this lecture, I'm only going to be doing the first switch here. So I'm going to be working on switch 1, but you're going to have to do switch 2. The configurations are almost identical. So if you follow along when I do switch 1, there should not be any big differences with switch 2. But you need to do switch 2 in order to work on the other parts. Alright, so going into our PC here, go to the terminal, press OK. Take a look here before you press OK. Look at the numbers here. You may need to know these numbers in case there was incorrect port configurations on the PC if you have to use a console connection in the skills exam. So make sure you know these numbers. Press OK. Now we're in the switch. So I'm going to maximize this here a little bit, make it bigger so you can see it. Okay. So in order to start configuring most configurations for switches and routers, what is the mode that you typically have to be in? It would be the global configuration mode. So we're going to enable to get out of user mode. We're going to go from privileged exec mode to global configuration mode. So to do the host name, we type host name and then where the host name is. So in this case, it says if we're in switch 1, we give it S1. So now notice that the command line information, notice the command line interface changed. It went from switch to S1 because we changed its host name. The next command that we're going to enter, because now we're on step 2, is the encrypted password. So remember, you can also create an unencrypted password. So the difference between those is encrypted password is enable secret and then whatever the password is, versus an unencrypted password where it's enable password and then the password. But in this case, we are doing encrypted, so enable secret, and we got to make sure that we type this exactly right because we don't want to avoid, we don't want to lock ourselves out of the switch here. So capital S, 1, capital C, and then all the rest lowercase. So capital S, 1, class with a capital C. Enter. So what we just configured is the privilege exec password. So once you go from user mode and try to access the privilege exec mode, it's going to ask you for that password. It's going to ask for S1 class. The next one, the next step, it says encrypt all plain text passwords. So this command allows for whenever you do a show run command, nearly all the commands are going to be encrypted when we run this command here. So it's basically just adding extra security to your switch. So we're going to do service password dash encryption. Press enter. Alright, so now we've encrypted all plain text passwords. So now we're going to the console. This is the main way that people access the switch. So it's the first, when you press enable, we're going to be affecting a password for that. We're going to be affecting basically the general environment for the switch here. So in order to access the console, remember it's a line. So we're going to be accessing the config line mode. So line console, and this is the main console, so 0. Now we're in the config line mode, so take a look at that. The command line interface changed. It's now config line. Where it's add our password, so it's password, and then this one is going to be S1, capital P, and then lowercase a s s for pass. All right. So make sure we got that right. Capital S1, capital P. All right, cool. Press enter. Now we got our password, but there's nothing enforcing that password to be used. How do we enforce it? We have to enable the login to it. So in order to enable the login, we just press login. Enter. Now they have to log in using that password. Now we're going to create a timeout. So we use executive timeout here, and then it says 2 minutes, but we're going to be using the seconds option here. So that would be 120. But if we want to use the minutes option, we could do 2 because the first number right here is the minutes, the next one is the seconds. But we're going to stick to what it says. 0 minutes, 120 seconds. Still 2 minutes, but a different way of representing it. All right, enter. All right, now we're going to do logging synchronous. So it basically means if you are in the middle of typing something, it's not going to exit out. It's going to keep your stuff here. All right, so logging synchronous. Next one is we're going to configure the history size. So basically, if you want to see past commands, we're basically saying we're going to show 35 recent commands that you use. That's the max limit that you can see. So we're going to press enter that. And that would be the end of the console line. Now the next one is the telnet lines. Now, there's two ways of doing this. One is a much simpler way, just a difference by one command. Because we're already in the config line mode, we can do line VTY 015, but people that don't recognize the same mode may just do exit and then do the same thing, line VTY 015. Remember, telnet lines are VTY lines, virtual telnet lines. And why we put 015? Because that's the range that we want to configure. We're configuring all the VTY lines here from VTY 0 to 15. So we're going to press enter. We're back in the config line mode. And now we're going to give a password, S1, capital V, lowercase ty, capital P, and all the rest lowercase. Make sure that's correct. S1, capital V, ty. All right, cool. Press enter. So now we put the password in, but there's nothing enforcing it. But take a look at this. It says local login. So now we're configuring like the SSH and telnet security here. So it's enforcing that it's keeping up to that, to what we want it to be. So we're going to do login local. Press enter. And then it says make sure the input only accepts SSH connections. So right now it can accept telnet or SSH connections here, but we only want SSH. So we can't use the telnet command in the terminal, the command prompt, because we're canceling out. We only want SSH. So we're going to add transport input SSH. It's going to make sure that the transport of the data, the input of it, is only SSH. I'm going to press enter. All right, same command here, executive timeout, but instead of 2 minutes, it's going to be 1 minute and a half, which is equivalent of 90 seconds. Going to press enter. All right, logging synchronous again. Enter that, and then a history size of 10 versus the 35 that we used for the console line. Press enter. All right, so now we're going to exit out of the config line mode because the next configuration that we're doing is a banner, and that's not configured in the config line mode. So banner, MOD, MOTD, which stands for message of the day. Now there's two ways of doing this. You can either use a hashtag or the $sign, but I'll stick with the hashtag here. And make sure whatever symbol you use that as well for the N, because remember, anything in between those symbols is your message. So gotta make sure that we're typing this right here. ADMINISTRATR, good. Access, capital A, and then capital O, lowercase NLY. Do our exclamation point, and then our hashtag. So in between the hashtags is our message. Press enter. That will appear when this the switch turns on. When you go to enable, that message should appear. Alright, so now the next one is configure the switch to prevent DNS lookup, so domain name service. We're preventing that because what this essentially does is, let's say you mistyped a command, or you mistyped a IP address, or mistyped a domain name. It's going to keep searching for it unless you know the combination, the key set there that'll get it to force the switch or the router to stop looking for it, because it's just going to constantly non-stop process of looking for whatever that command or name of the domain or the IP address is. So we are going to we don't want to do that. So no IP domain dash lookup. Remember, no is generally the word that you use to cancel out a configuration. All right, so now we have prevented DNS lookups, and now we're going to go into the ports here. We're in the config mode. We got to get to the config if mode, the config interface mode. So int, or you can use interface, gig 01, or you can type the full 1 gigabit Ethernet, but I'm just going to stick with gig 01. And now we're in the config if mode. All right, so now we're going to give it a description. So we use description and then the description. Capital CONN, connected to capital WAN VA router 1. So it's whoever is viewing it, the person that's viewing the port, he knows that that port is connected to the router to get to the WAN. So we're going to press enter that. And remember, like I said, a switch has all of its ports up by default, so we don't have to worry about that. Now we're going to go to the next interface, gig 02. And now we're going to give it a description. And it says if it's switch 1, we're going to say connected to switch 2's LAN. Make sure that's typed right. All right, so now press enter, and it's up and running already. So now we can go to the fast Ethernet one. So int fa01, and now give it a description. Connected to PC1's NIC. Network interface card. So connected to PC1's NIC. All right, and then the port's already up and running. So now we're going to go to our fast Ethernet 24 port and give it the description of connected to SE1 server 1. All right, so now it says here for the interfaces, so there is a argument here. So if we're in switch 1, we're going to be using this one. So we have to configure multiple ports, and it's the same configuration. So there's two ways of doing it. One that's a really long way, or a short way, and I prefer to use the short way as much as I can. So instead of going to each individual port, which I mean is like typing INT or interface, fast Ethernet 2, interface fast Ethernet 3, and so on, we can do a range and configure multiple ports at once. So we can do INT range fast Ethernet 0-2, and because the first number is 0, we only do -24. But if it was fast Ethernet 0-2, and then we were trying to do all the ports in FA0 slash the number to FA1 slash something, then we can do that. But since it's falling under the same range with the 0 in front of it, we can just do -24. So it's configuring fast Ethernet 0-2 to all the ports to fast Ethernet 0-24. So now we're in the config if range mode. So we're configuring multiple interfaces or ports. All right, so we have to administratively shut it down. So remember, all the ports in the switch are by default up and running, but we want it to be administratively down. So we just type shut down or shut, and now all those ports are administratively down. All right, so now we have another range here. The next step is interfaces FA02 to 23. So because we're in the same mode, we can just type in the range here, dash 23. And now we're configuring new range, and we're giving it a description of administratively down. Administratively shut down. Enter. All right, and now we can exit out of the config if range mode, or we could do the command in the config if range mode, because it is still interface, because we would be configuring the VLAN. But in this case, I'll show you just the exit command, get back out of the config if range mode to the config global configuration mode. All right, so now we're going to go to our interface VLAN 1. We're going to give it the description here of LAN 1 VLAN, virtual local area network. And we have to give it the correct IP address. So we have to do IP address, and then we have to go back to our IP table here. Switch 1 has an IP address for VLAN 1 of 194.168.200.1. And then for this command to work, we also have to include the subnet mask. So 255.255.255.128. Press enter. All right, so now we have our IP address and a subnet mask. But by default, the VLAN interface for switches and routers are shut down. So we have to tell it to be up and running. So how do we do that? We use no shutdown. We don't want it to be administratively down, so no shutdown. And now it's up. And now we finished the VLAN 1 interface, and now we can go to the default gateway. We can configure its default gateway here. So I'm going to exit out config if mode, do IP default dash gateway, and then now we have to go back to the IP table here. Switch 1's default gateway is 194.168.200.2. In this case, for default gateway, you don't include the subnet mask. So you just press enter. Now it has the default gateway. All right, so now we're going to give it a domain name. So for commonly configuring SSH, the first command you generally have to put in order to do the others is doing a domain name. So we're going to give it a domain name of Cisco-S1.com. So IP domain name Cisco-S1.com. And keep in mind, we're in the global configuration mode for this. Press enter. Now it has that domain name. Now we're going to create a crypto key. Now this is very important here. You want to make sure that whatever bit number you put in, when it comes to keys, it can be tricky. If you type something in wrong, you have to use the zeroize command to get rid of that key, because it could affect the whole SSH configurations and connections if you type that wrong. So let's work on this. So crypto key generate, and we're creating an RSA key. So CRYPTO key generate RSA. And now it says how many bits is in the module list. So how big is this key going to be? How encrypted is it going to be? So right now we said 1024. So 1024 bits. Press enter. And now it is creating 1024-bit RSA keys. After we do that, we're going to give it the SSH version. In this case, 2, because SSH version 2 is a lot more secure and encrypted than the SSH version 1. And now, since we gave it the SSH version, now we want to create our account. So if we want to do a SSH connection, we have an account, a way to access it. And if I'm the administrator, I want to create an administrator account first before I create any lower access level accounts for any employees. So since we're creating an administrator account and we want it to have the highest permission level, we have to use a little bit bigger command. We're going to be adding privilege and the number 15 because 15 is the highest permission level that you can give to an account. So we're going to type username, admin, because that's the name of the username account, privilege, 15, we're giving it the highest permission level, secret, now we're creating the password, and it's capital S, 1, capital A, lowercase d, and admin, capital P, and then all the rest lowercase. Make sure that's typed right, S1, admin, pass, press enter. Alright, and now that is all the configurations that we have to do, but in order to complete this, we need to also save it to the running config or the non-volatile RAM. So we could do two things. We could A, exit out of the config mode, do it in the privilege exec mode, which is the mode that you use for copying the running config to the startup config file, or you can use the do command. In some cases, you can use the do command in front of the command that typically you would use the do command in front of a command that may be in the wrong mode. So for example, if you wanted to configure the banner, well, in the config if range mode, you can type do and then banner MOTD, the message, and then press enter. But as long as you have the do in front of it, it would work. So we're going to do copy run start, which is equivalent to copy running config startup config, and then press enter. It saves it to the startup config file. And that's it for switch 1. So if you follow what I did for switch 1 here, switch 2 is identical to switch 1. And just to see here what we did, banner, it shows the banner, and now it's asking for a password for the user mode, and once we log into that, then it's going to ask the password for the privilege exec mode. So make sure you have those passwords typed right, or write down whatever password that you use instead to make sure that you didn't get locked out of the PC or switch or router. Make sure you don't get locked out of the switch or router. Okay, so now we configure switch 1. I'm skipping switch 2. That's up to you to do, but again, remember it is required for part 5 and part 6. But now we're going to part 4, the router configuration. All right, go to router, go to our command line interface, and let's start configuring the router. All right. So again, a lot of the commands have the same modes as a router would when we did it in the switch. So in order to configure the host, we have to be in the global configuration mode. And we're giving it a host name of R1. It changes. Look at the command line interface. It changed from router to R1. Now we're creating the encrypted password. So enable secret R1 class. Make sure that's typed right. R1 class. Enter. Now we're going into the console line. password R1 pass, enter. Make sure the login's enforced, so log in. Executive timeout 2 minutes using the seconds option, so 0120. Logging synchronous. You could just type that, that'll work as well. There, most of the commands, as long as you get most of the word in and it's typed right, it should work. And then history size 35. Going to our telnet lines, or virtual telnet lines, V2I. Password R1 capital V T Y PASSS. Make sure that's typed right. Okay. Login local, because we're doing the SSH. Transport input SSH, making sure the input is only SSH connections. Then executive timeout of 90 seconds, or 1 minute and a half. Using the seconds option, 090. History size of 10, so you can only see 10 commands. And now a new line, unlike the switch, we're configuring the auxiliary line. So line AUX 0, and then password R1 pass. Login. Exec timeout 2 minutes, 0120. Logging synchronous. History size 35. Alright. Exit out of the config line mode. Banner MOD, message of the day. Administrator access only. Don't forget the exclamation mark, hashtag. Alright, so now we're going to prevent DNS lookup. So remember the no part of the command. It's saying don't do this. We're disabling it, so no IP domain -lookup. Alright, so now we're going into the ports. So right now we're essentially configuring the default gateways for the network. So go in, get INT, gig 00, gigabit 00. Now we're going to give it a description. Connected to LAN 1 VA switch 1, S1. Now going back to the IP table, we have to give it the correct IPv4 address and subnet mask, correct IPv6 address and prefix notation, and correct IPv6 link local address, and be up and running. Alright, so going back to our IP table, router 1, gigabit 00. So again, just like how we did with the VLAN for the switch, IP, ADDR, or IP address. You can type the full thing, or you can do ADDR. Now, give it the IP address, 194.168.200.2. Don't forget your subnet mask, 255.255.255.128. Press enter. Now we're giving it the IPv6 address. So it's just like the IP address command, except we're adding v6 to it. IPv6 ADDR. And now going back here to get the full part, so we're giving it the 001. So in this case, it's the first subnetwork, so 2001 DCB8 ACAD FFFF BADE 9 AA9 CAD0 0001, and then you have to add your prefix notation afterwards, kind of like how you have to add the subnet mask to the IPv4 address command, and our prefix notation is 123. Press enter. Next, we're going to add the link local, which is equivalent to like a default gateway address. So IPv6, ADDR, IPv6 address, FE80::1, and then you have to add the words link-local to it. So going back here again, link local address, FE80::1, and then you have to type link local to tell it to be kind of like the default gateway. Alright, so making sure we have all the information for the port here, press enter to that. Alright, and remember, like I said, the router, all of its ports are typically automatically shut down. So we have to enable it. So we have to do no shutdown, or no shut, and now it's up. And now take a look at our topology here. Fast forward time, now the router and the switch here can contact each other. It is now open for them to talk to each other. Since we haven't configured switch 2 yet and the other gigabit port, the default gateway for the other network, it's not going to be yet able to talk to the other network. Even if we create the IP default gateway here for this port and turn it on, it may still not be able to contact this network because as of right now, switch 2 is not configured. That's why I highly suggest going back and configuring switch 2 so you can practice the commands I've shown you, but also so you can work on the other parts because the network has to be able to ping each other and communicate with each other. But anyway, going back here, now we're going to gigabit 01. So int gig 01 description connected to LAN 2 via switch 2. Now we're going to give it the IP address. So we need to go back to our IP table. And our address is 194.168.200.130. Same subnet mask. Press enter, IPv6. And the address is identical except instead of 2001 is 2002. DCB8, ACAD, FFFFF, BADE, 9AA9, CAD0, 0001/123, because we have to include our prefix notation, and then press enter. Add our link local. It's almost the same, except instead of 1, it'll be 2, so FE80::2. Add our link local to it, and then press enter. Now we have our IP addresses, and now we have to tell it to not be down, and now it's up. So now what we're going to do is we finished 8 and 9, the 2 default gateways, and now we're going to configure the gigabit 02 port where it's already shut down by default, but just to make sure, we're going to tell it shut down anyway, and then we're going to give it a description of administratively shut down. So ADMINISTRATIVELE. Alright, cool. Alright, so now we're going to exit out of the config if mode. Go back to the global config. Give it the domain name of cisco-r1.com. Create our crypto key, our RSA crypto key. It has a different bit modulus. It is 2048, which I believe is one of the highest bit modulus that you can do, at least in this router version that we're using. Make sure we type that right, 2048, enter. Alright, now we're going to make it run IP version 2, SSH version 2. Give it the admin account. So remember, username, admin, privilege. Remember, we have to give it the highest privilege, which is 15. Secret. Now we're creating the password, which is R1ADMIN, capital P, pass. Make sure that's typed right. R1 admin pass. Enter. Now here's some new commands, which is dealing with SSH. These 3 commands that are coming up typically only work for the router level. So router 1, it says we have to create a login block, which is basically added security for when someone is creating an SSH connection. So we're going to do login block 4. So looking here, it says it has to lock the user for 90 seconds. So 90, because this part, it has to be in seconds. There's no minute option. It has to be seconds only. So if there was 2 minutes, you have to do 120. All right, and so the next part of the command is attempts. So how many attempts are we allowing it before it gets blocked? We have 3 attempts. And if these attempts occur within 30 seconds, then it will lock the user for 90 seconds. So block for 90, attempts 3 within 30. Press enter. All right, now we are requiring for any future password creations or accounts to be set up for passwords or anything relating to passwords, we're setting a minimum security length for those. So security, password, mid, length. So security, passwords, mid, length, and then the character amount. So it requires a minimum of 8 characters. So we'll put 8 there, enter. All right, now we're creating a SSH timeout of 120 seconds. So if I'm the user and I create a SSH connection and I'm inactive, did no commands or typed anything, and it's going to kick me out if I've been inactive for 2 minutes. So IAP SSH time -out 120. And it's also a seconds only thing. So if it was 2 minutes, you have to use 120. Press enter. All right, and then it says enable IPv6 communication and routing. As of right now, even though we put in IPv6 addresses and link local address to the port, it still can't communicate IPv6 packets until we give it this command to allow IPv6 packets to come into the router. So in order to do IPv6 communication, we have to do IPv6 unicast-routing. Press enter. Now it is able to run IPv6 packets. And the last part is save the running configuration to the nvram/startup configuration file. So I'm not going to exit out of the global config. I'm just going to do copy run start. Again, it's equivalent to copy running config, startup config. Press enter. Press enter again. Now it is in the startup config file. It's all saved. I'm going to exit out of that, exit out of that. All right, so that concludes part 4, the router configuration. That's as far as I'm going in the configuration and the lab itself here. Part 5 is going to be dealing with testing and troubleshooting, copying the running config to a TFTP server. Then later on, you're going to be creating an SSH connection and running some show commands to see some extra information about the router and the switch or any other information about the devices. And you may have to do also another TFTP command. So I highly suggest doing those parts because those might be some extra commands that you need to know for the skills exam. So nothing's hurting from going back and looking at those parts here. So this concludes this online lecture. The video discussed the configuration concepts and commands for switches and routers. In the lecture, I also discussed the modes, the commands that were used in, and how to configure PC IP information. I like to remind whoever is watching this lecture that they need to ask themselves if they truly understand this topic. This is a major item for the final skills exam. There will be no notes or command sheet allowed, so these commands need to be memorized. You have to know these commands. There's no excuse for that. This idea applies to Cisco 2 and other Cisco classes, so when it comes to skills exams, you have to know the commands regardless. It's not just Cisco 1. If you have any questions or concerns dealing with PC, switch, or router configurations, I suggest contacting the tutors for this class or the professor. I hope you enjoyed this lecture and feel more comfortable with network device configurations. Till next time, you have a nice day.